Right now, we are witnessing a massive biological paradigm shift in agriculture, and it's serving as the direct catalyst for a staggering $18.75 billion market revolution. If you're operating in the agtech space, or honestly, if you simply eat food and care about the future of the planet, this is a monumental shift you absolutely need to understand. Welcome to today's Explainer. Let's dive right in.
Here is our roadmap for today. We'll start with the crisis of modern agriculture, then unpack the Holobiont concept, explore Archaea's control valve, break down the BNI nitrogen mechanism, and finally, look at that massive $18.75 billion market.
Part 1. The Limits and Crises of Modern Agriculture.
For decades, our main approach to increasing food production has basically been just pouring more and more chemical fertilizers onto our fields, but we're trapped in a devastating cycle. When farmers apply these inputs, a massive portion of it isn't even used by the crop. Instead, it converts into toxic nitrate, which leaches down and severely pollutes our water systems. And even worse, it releases N2O. That is a greenhouse gas 310 times more potent than CO2. We are literally watching money evaporate into thin air while our soil microbiology gets destroyed. The old way is reaching its absolute breaking point.
Which brings us to Part 2, the entirely new concept of holobionts.
To escape this dependency trap, modern science has handed us a completely groundbreaking new framework for understanding plant life. Instead of treating a plant as this solitary, isolated organism that constantly needs to be artificially fed, we now understand it as a holobiont. Basically, the plant and the wildly diverse microbes living in and around its roots form one single, inextricably linked functional network.
Think about the contrast here. The old paradigm treated plants like isolated machines. If they lacked something, we had to artificially pump it in from the outside, wasting incredible amounts of money. The new holobiont paradigm completely flips the script. It efficiently harnesses the entire microbial ecosystem to naturally promote plant growth, drive incredible nutrient absorption, and build deep resilience to environmental stress. It is a total reimagining of agricultural biology.
Part 3. The control valve function of Archaea.
Deep within this holobiont network, there's an invisible orchestra conductor running the show, known as Archaea. These are ancient, incredibly tough microorganisms that act as a master controller. In an environment without Archaea, microbial waste just builds up. The metaphorical valve gets completely closed, and beneficial bacteria literally stop working because they are choked by their own byproducts. But when Archaea are present, they act as an open control valve. They smoothly absorb the waste. This allows those beneficial bacteria to continuously break down organic matter and deliver nutrients without stopping, and crucially, without emitting dangerous greenhouse gases. It really is nature's perfect optimization engine.
Part 4. The Mechanism of Nitrogen Retention by BNI.
Working right alongside that Archaea control valve is nature's very own nitrogen brake system. It's a fascinating biological process called biological nitrification inhibition, or BNI, and it solves the exact fertilizer leakage problem we talked about earlier. It happens in 4 really elegant steps. First, the plant's roots naturally exude a highly specific inhibitory substance. Second, this substance pinpoints and suppresses the exact soil microbes that cause fertilizer to rapidly break down. Third, this slows down the rapid conversion into highly leachable nitrate. And finally, the nitrogen gets safely locked right there in the soil around the roots as easily absorbable ammonia. The plant is essentially managing its own pantry, so the food doesn't wash away.
And we aren't just talking about niche experimental crops here. International research has successfully developed this BNI technology across massive global staple crops: wheat in India, corn, sorghum, and even tropical pasture grasses. By utilizing crops optimized for BNI, we can massively slash chemical fertilizer waste, dramatically lower costs for farmers, and simultaneously protect our groundwater from toxic pollution.
It's no wonder researchers are boldly calling this a second green revolution. BNI's root secretions literally put the brakes on the nitrification speed. By doing so, it dramatically reduces agricultural greenhouse gas emissions, especially that terrible N2O we mentioned earlier. It perfectly balances the dual goals of maintaining super high crop yields while actually moving the needle on climate change mitigation.
Part 5. Growth Factors of the $18.75 billion market.
Having seen the microscopic mechanics of Archaea and BNI, let's rapidly zoom out. We need to understand how this biology is actively reshaping the global macroeconomy. That 50% figure? It isn't just an abstract scientific wish, it is backed by severe regulatory catalysts. The European Union's farm-to-fork strategy has strictly mandated a 50% reduction in chemical pesticide and fertilizer usage by the year 2030. When governments enforce hard limits like this, the global market is literally forced to rapidly adopt these exact biological, holobiont-based solutions.
And it definitely is not just governments setting the pace. Corporate giants are laying down the law. Walmart is mandating zero pesticide residue for over 2,000 of its suppliers. Heavyweights like PepsiCo and Cargill are aggressively shifting their massive supply chains toward regenerative agriculture. This incredible corporate demand triggered a staggering $1.8 billion in agricultural biotech investments in 2024 alone. Plus, we're seeing rapid integration with AI and synthetic biology to accelerate these discoveries. Make no mistake, this is a one-way structural market shift.
Fueled by these exact mandates and a massive 14.7% compound annual growth rate, the agricultural microbiome market is accelerating at breakneck speed toward an incredible $18.75 billion valuation by 2030. The financial upside for those who adopt this early is, frankly, staggering.
Now, historically, the biggest roadblock in biological agriculture has been inconsistency. A microbe that works perfectly in one field might completely fail in another due to different soil or crazy weather. But archaea entirely solves this reproducibility problem. Because archaea are incredibly tough and act as that stabilizing control valve we discussed, they ensure the microbiome works efficiently across totally diverse, harsh environments. This turns a highly variable biological science into an unbeatable, consistent business advantage. It's a true competitive moat. Next generation food security.
Ultimately, embracing the Holobiont is not just an eco-friendly farming trend to make us feel good. It is a vital, structural macroeconomic shift required to ensure global food security in the face of climate change. We have to start working with nature's invisible networks, not continuously fighting against them. So, I will leave you with this pivotal question to ponder for your own strategy. Will you continue to rely on volatile, increasingly expensive chemical fertilizers, or will you ally with the Holobiont to lead the next multi-billion-dollar market revolution? Thank you for exploring this fascinating topic with us today. Keep learning, and we'll see you in the next explainer.